So we're doing section 3.5, example 6. We're on page 119. They do give you a little verbiage before on page 118 before doing example 6. But basically it's saying, how can results be verified, like you did in example 5, if the known value is not given? If you don't know what the known value is, well, then you're going to have to compare the results. You're going to have to do several repeated experiments and take those results and get the average. So if you did 2 experiments, you're going to take those results and add them and divide by 2. If you did 3 experiments, then you're going to take and add up all 3 of those results and divide by 3 and so forth. You're taking the average. Okay, keyword here, average. All right, repeated experiments, you're taking the average. So let's look at example 6, and then you're going to find the percent difference, not the percent error. And I'll explain to you a little bit of what does this mean and what is this versus what this means. But if you notice that you've got kind of a similar formula here, you're subtracting something, dividing something, and multiplying by 100%. And you're doing the same thing over here. So let's just see how that compares differently. They're using some different terminology here. So example 36, Susan found, she had a cylinder, let's just say it's a pop can, a cylinder, and she used a water method. You're all in science, so you probably know that H2O means water. So she used a water displacement method to find the volume. And when she did that, she got this results for the volume, which was 15.64 centimeters cubed. Remember, when you're dealing in volume, you're dealing in cube units. And then on her second experiment to find out what the volume of the cylinder was, or the can, she took actual measurements and used the volume formula. And when she plugged that in, she ended up getting 14.01 centimeters cubed. So she did 2 experiments to try to find the volume here. So what we need to do, we don't have the known value, it's not known, so we're going to take the average. So we're going to take these two, the 15.64 plus the 14.01, add them together and divide by 2 because we've done 2 experiments. When we do that, we end up getting 14.825. All right. So this basically is kind of like, so that's the average. Okay. Now, remember before we took the change experiment value and the known variable when we were dealing with votes, we were doing the change. Okay. Well, this is kind of the same thing as the change, only we're taking the result of the first experiment minus the result of the second experiment. So let's just do that. The result of the first experiment. So we're going to get this one here, 15.64 minus 14.01. All right, and we're going to take the absolute value. I'm just plugging in, but this actually is the change. Okay, over the average. This was the average, 14.825. And of course, we're multiplying all that by 100%. And I guess I've been doing this earlier, so I'll just be consistent here. All right. So all I did was plug in what I know here. So when I subtract this out, I'm going to get 1.63, and we want the absolute value. So it's going to be a positive all over 14.825 times the 100%. And actuality, 100%, you can just move this decimal when you're multiplying over 2 places if you want. So when we do that, I end up, and I'm going to go down here now, we're going to get 163 because we moved our decimal over 2 places, divided by 14.825, because all I did was I multiplied 100% times that. And with that, you get, when you do that on the calculator, you're going to get approximately something like 10.99. We want percent, don't we? So I don't want to give it my percent. Let's go back. Let's go ahead and leave this as a decimal. Sorry. Right? We're going to divide that out. And this is times 100%. So we multiply that, we're going to get 10.99%. And they're having you round. So you're going to get 11%. Okay? Now you could have done that. What I was doing here before is I was moving that over and I was making that 163 over 14.825. And then you're getting some number and we move the decimal back over and add our percent. So we're going to get 11%. But they chose to do it this way, so we're going to do it this way. Hopefully that didn't confuse you, but I know I'm babbling here. So our error difference is 11, percent difference is 11%. That seems awful high versus like a 1% error. 11%, definitely is lower than 50% error. But what is the difference between a percent error and a percent difference? If I say I had 11% difference error, then you're going to know that I calculated this by using the average of several experiments. If I say the percent difference, you know I have done that. But if I'm using the terminology, I did an experiment and I got the percent error to be 11%, then you know that when I calculated that, I had a known value to begin with. So that's just kind of the difference in terminology. When if a scientist is talking about percent difference, okay, they did several experiments and took an average. They're talking about percent error. They actually knew what it should have been and compared it to the experiment that they had. So I'm going to give you a practice problem. So let's clear the board. Actually, I'm going to clear the whole board. And here is your practice problem. Find the percent difference. So if you see me say percent difference, you know you're going to be using an average. All right, find the percent difference. So that's what you're doing. Find this. If for 2 experiments, I did 2 experiments, okay? The first experiment gave me this result. You don't even have to know what the experiment is. And the second experiment gave me this result. So this was the first and the second, first and second here. These were the results, all right? So go ahead and pause the video, work this problem, then come back and let's check for our answer. All right, so if you got 3.3% as the percent difference, if you got this for your answer, then you've done it correctly. But let's go ahead and work it. Remember the percent difference was taking that first one minus the second one, and the absolute value over the average, right, times 100%. That's our formula. So let's do that. So here's the first and the second. So I'm going to go ahead and find out what the change is. Right? So this is going to give, this is plus. So when we subtract here, we're going to get 0.0. We're going to get 0.6. And it's a subtraction, it's a negative. That's the change. All right, so what I did is I just figured that out. But they want the absolute value of a negative 0.6. Okay, I just figured this one out. And the average, oh, we didn't take the average. So now we got to do the average. the average is 7.8 plus 18.4 divided by 2, and that's going to give you 36.2 divided by 2, which gives you 18.1. So the average is 18.1, all times 100%. Okay, well, the absolute value of a negative is positive, so we're going to make that positive, times the 100%, correct? Which, that's going to end up giving me 60, and I should make the dot smaller just so you don't think it's a minus sign, but 60 over 18.1, which gives me 3.31, which is 3.3%. So that was our answer for our practice. Practice problem. And I think that is all the examples in section 3.5, if I am correct. All right.